Center and has developed pioneering technologies including graphene-based supercapacitors, MEMS biosensors, and microfluidic devices. His contributions span both advanced R&D and transformative academic leadership. Thank you, sir. Now I invite the moderator of this session, Professor Dr. Pradeep Kumar Dimri, sir, Dean of Student Welfare and Senior Professor of J.C. Bose University of Science and Technology, YMCA, and Honorary Secretary of I Faridabad Local Center, to join us on the desk. Thank you, sir. As a mark of respect, growth and sustainability, we begin this session by presenting saplings to our distinguished panelists. I request Engineer I.S. Oberaj to please join, sir. And Mundada, sir, please. Shamim, sir. Shamim, sir, please.
सर आपका बहुत बहुत स्वागत है पुनः सर। यस सर, वेलकम यू।
थैंक यू सर।
इधर सामने देखिए सर, सामने वेट करना चाहिए सामने।
I request Dr. Pradeep sir and I.S. Oberaj sir to present our saplings to G.K. Sharma sir.
सर सामने।
Next is our Dr. Kulwan Singh sir. Kindly greet him with the sapling. Now I request I.S. Oberaj sir to present a sapling to Dr. Pradeep sir.
मैंने कहा था he deserves sir more than a sapling. अरे आप दीजिए सर।
Thank you sir. Thank you sir. With this warm gesture, we formally commence the panel discussion. Now I request moderator Professor Dimri sir to take over forward the discussion and guide us through this intellectually enriching session. Thank you, sir.
Thank you, Dr. Lalit. So, warm welcome to all the audience. All the audience is very keen. Maybe the fatigue factor, because this is the second day of the conference. But nonetheless, this is going live, sir, on our Facebook page and YouTube page. So, anybody who can watch it, please watch. So, the topic, as I have already has been, told by by Dr. Lalit, that future of electronics engineering. So, topic is very wide, sir, and we have a very, experienced panel. All barring Dr. Kulwant, everybody has got grey hair, and they have not, grayed under the sun. It is rather than leaders of the laboratory where the hair is grey. So, a warm welcome, sir. So, the format we will keep is first introductory. Everybody, I request all the panelists to give their opening comments within 2-3 minutes, and then we will open it for sector-wise what we are doing. So, we are living in Faridabad, and Faridabad has got two adjectives associated with it. One is that it is one of the most polluted city, and second one is it is also on the list of smart city chosen by Government of India. So these two do not match, but India is a land of contradiction. There are some good things, there are some bad things. Electronics, a lot of things are happening. In fact, this session time will be very less to dwell on the areas. We are talking of 6G, we are talking of smart factories, we are talking of smart warfare, in every sector, even civil engineering, all these green buildings, then energy conservation, electric vehicles and all. So next decade is going to be very interesting from the point of view of electronics, and rightly our government has taken a very ambitious plan to achieve something before 2047, a Viksit Bharat. So there are a lot of key, programs of Government of India like Digital India, Atmanirbhar Bharat, and Atmanirbhar Bharat, Sakshar Bharat, Viksit Bharat. So all these things, and in all these programs, I think that electronics is going to be a key factor. But there are challenges also. Recently, we have seen that in May there was Operation Sindoor, and most of us know that the Operation Sindoor was fought. It was a electronic warfare without operating, without displacing or without advancing the infantry. We achieved much more than in previous this thing also. Although information warfare did not go that well, some people suggest. So I would start with Professor Samir Ahmed. He has a vast experience as a director of CD Pilani, and CD Pilani has been on the forefront of names, smart sensors and micro VLSI and all these things. And then he also has the experience of academic administrators, because he was the vice chancellor there, and he has written a lot of books. Sir, where do you see and what is your perspective on the future of electronics area?
Well, good morning to all of you. I think I am audible, right? Audience sitting here, so it's not okay. So, if you ask my opinion about electronics, my opinion is the same as Professor Devi has already proposed. You may like or not, electronics is going to be there. Come on. Now, when that is the situation, then we have to think about it in a very, very effective way. If you want to make best out of it, your strategy should be such that you don't waste time in discovering things, rather using them. After COVID, it has been completely proven that your way of providing a solution to a problem has to change altogether in a fundamental way. Nobody is going to wait for it. People want solution and they want it. They want it to have a study. Today is late. Tomorrow it may be. Don't bother about it. Now, having this kind of situation in the area of electronics, and this is the area where it is maximum, you have to be very careful. I am taking an example of those who are the leaders in electronics and they are progressing. I visited San Jose and found out the name of those well-known producers and manufacturers of semiconductors and semiconductor systems, things like that. They completely removed and new boards came up and they started doing business. Not that they are very smart, no. Their strategy was appropriate, meeting to the demand of the day. Now, if, in a nutshell, you want my opinion, you should do electronics, but do it only for solving your problem. And then go ahead. Don't wait. And another problem of Indian scientists is that we want to discover everything from ab initio. This is perhaps in our genes, you can't change it. So the moment you think, then you start from nut and bolt, and then after that you want to do rocket. Everything I have seen, and people have wasted enough of time in that. Okay? If something is available readily, why don't you take it and use it? Why do you take pride in that? For the first time in the country, I have done this. What? In a test tube, some change in color, and that is electronics. Please, don't do that. My experience is that if you have to make a radar, make a radar. Now, don't waste time in, producing components. Make a radar and solve the problem. By the time you make the radar, your radar is obsolete. So, point is that whichever part is available, whichever progress is made known to you, or ultimately knowledge, if knowledge is available, take it, absorb it, and then apply it to the latest problem which you are facing. That also not very generic. No, don't go for generic. For generic professors are there, they will do that. Industry should take the problem and find out the solution, get borrow or scheme, do anything, nobody borrows. Fortunately, at present time in the country, this kind of thinking has started coming up. I am really very happy to know that when we were doing semiconductors in early days, that everyone, no, don't do it, because it is not according to the policy of the government. Government is, Swadeshi, this Deshi, that Deshi, and whatever you call, never a science, it was only protecting somebody's, dictum, that's all. So please don't do that. As a free thinker, free mind, to solve problem, you apply and do that, and you are winner. Then it is a very good situation. Otherwise, you will be always left over. So with this, I would like to conclude. I may be, if I have offended somebody, please forgive me, but this is a fact which I have noted for the last 40 years of my R&D in electronics, and 20 years of my experience, which perhaps you don't know, is in the area of nanobiotechnology. As a matter of fact, I left, electronics, working in electronics, because of this frustration. That the moment you put your finger on something, somebody has already done it, produced it, and manufactured it, and spread the whole world. That is the situation. By the time it comes to us, it is already late. When it comes in between, 2 years minimum time has gone. So, keeping all these things in mind, if you want to do electronics, you should move with the same Moore's law of speed as my colleague Dr. Sharma will collaborate. You have to move with the same speed as Moore's law, not below that. If you do that, then you will be left out. You will be either below the curve or above the curve and nowhere on the curve. Thank you very much for patient listening.
Thank you. So, I would like to know the perspective of Professor D.K. sir.
Yeah. Actually, I look very differently as far as the electronics is concerned. My way of thinking is how we solve real world problems using electrons. Electronics is basically, it's all about starting from electrons. Today in AI era, now real world problems people are solving using large language models like ChatGPT, Meta's Llama model, Copilot and so on. Now the thing is, all these models, when we are going to, you can say, run, we need hardware. And hardware is nothing but electronics. Right? Now, you can say that, okay, people have done. People have, you can say, big data centers. NVIDIA is, you can say, is basically supplying all sorts of GPUs. Now, the thing is, if you look at the future of data centers, number of GPUs, enormous number of GPUs. Then what about the, you can say, heat generated by these data centers? Then the climate. You will see that there is a change in the climate. So basically, the electronics is when you are designing your own GPUs, you have to design thermal aware GPUs. It is not something that GPU, NVIDIA is pioneer in this GPU business. And why I am saying it is basically electronics, it will come to again the chip design sort of thing. Recently, I think 3-4 days back, NVIDIA has given $2 billion to Synopsys. It's an EDA company, electronic design automation company. That is the tools which you use for the chip design. So the thing is, start from, now we have to think this electronics and communication or communication in AI era. Whatever is needed, because future is lying in AI. Okay? Though means I am a very old user of AI, means I taught artificial intelligence at British in 91, 92, 93. And since then I am doing research because I was in the chip design group. Professor Shamim Saab knows this, that I was associated with the chip design group. And I took both the things, AI and chip design together. And when I retired in 2023, I gave a very good project to IIT Gwalior on AI chip design. And future is basically AI chip design. When I say that it is AI chip design, means hardware aware deep learning models. The idea is basically, you see, when I was at Darmstadt University of Technology, Germany in 1990, I was associated with the Institute of Microelectronic Systems there. There was a big group working on neural networks that time. And I was also working in a tool development side, how you can simulate neural networks. But the problem that time was that you can say memory, because of the semiconductor advances was not that much, which you see today. Memory, the computational power. And that's why you see that could not took off. But when now computation power is available, when you have the memory available, now you see that you can say the area of deep learning basically it is started. Now you see when we say, why I am saying that okay, think in terms of the cost-effective solution. It is not just because the NVIDIA has done GPU, okay, they have look at the Google, they are talking about TPUs, tensor processing unit, ARM, that is neural processing unit, and so on. Now, can we think of in these designs thermal aware or energy aware? Because the most important thing is whatever model, AI model you have or deep learning model you have, we want to run on our mobile devices. Can we run today? We can. We are unable to do it because computational power is again limited as far as the mobile device is concerned, and the memory. The other thing is, in the drone business, you have talked about operations in the drone, the controller chips in the drones. Now you see, can we run the AI models? So it is all about electronics. You cannot say that it is supposed to computer science. No, computer science is incomplete without this hardware. And hardware is all about electronics. So I think we should think in terms of the kind of the architectures which electronics and communication people can say easily focus with the help of some sort of, now today models are available, the ChatGPT, you can use ChatGPT, learn things, and then you can try your new things. Now, you can say that ChatGPT is there, now the language models are there, then there is no need to do anything. No. Why I am saying this? Because, you see, when you want to run these sequential models, it is, you can say, working in the cloud computing environment. Now, if you have the, you can say, your data private, okay, the privacy is very important, the security of your data is very important, then you want to run on your own devices. So that way you have to think in terms of the hardware, in terms of the, you can say, electronics, so that you can address these, you can say, challenges. Another thing is, it is communication. You are talking about 6G. And recently at Slide Longobal, I delivered because 3 hours lecture on deep learning models for 6G communication. Means it is not just 6G, technology is fine, but the thing is, can we have, we can say, the models for having the efficient 6G? Because it is influx of, we can say, electronic devices. You are talking about, we can say, the IoT, the edge devices. People are talking today as AI. So these are the things where we can see the future. And in coming 10 or 15 years, you will see all sorts of things people are talking about in terms of AI. So this is my totally comment.
Thank you. So now I will request Professor Purwan to more deliberate on this topic.
Thank you very much for inviting me. And really it's very tough if you are basically invited as an expert in front of the gurus. I learned everything from foundation of electronics from city planning. In fact, the lab founded by Professor Masar, he was the director of city. And when he retired, at that time I joined as my MTech intern, I can tell. So, yes, what I learned actually from really, and I'm also very fortunate actually, I could basically work with the senior professors, senior scientists, and strategic and visionary peoples. And what today's topic you have basically decided for the panel discussion is scope of electronics and communication in future. But obviously your theme for the seminar workshop was IoT sensor systems. So as mentioned by the, obviously I can say once again my gurus, none of the basically system can basically functional as a automation or completely automated without a root that is electronic systems basically. So if I'm talking about electronics, that means it's completely functioning based on the game of the electrons on conductive materials. So people are continuously looking to make it smart, and trying to make it as smart as a human, right? So when we are talking today's robotics and drone and anything else, if I can ask with anyone else, I can feel, I was thinking also, till my student, till my research, till my faculty, till my scientific journey, many hard disks I have replaced. But my brain is the same. So this is one kind of memory and microprocessor, right? So every people trying to make the electronic system as close to nature means human bodies. So drone, robotics and all the things is a part of the same. So if we need to reach up to that level, so innovation and complete basically you can understand that from the root to the move for the today's requirement, we need to do the basically study, innovation, research and all, etc. Irrespective of for the India perspective, what I have seen that a lot of work is being done by the CSI laboratories, because not only CSI planning is one laboratory related to electronics domain. Similarly, for different domains, approximately 37 labs was architect of 7 or 8 for different areas. Important part is basically to work in the team, as I mentioned. What today we have, how we can solve the realistic problem, and we can basically feel that yes, this is innovation is done by our own group. So collaboration and team is very important. For short meeting, this is also once again mentioned, yes, team is very important. It is very challenging in India, in fact. So I think that if another round will be there, then I can discuss on that. So I will tell two things basically. If I am talking, I am working on only resistance phenomena. I am working on only capacitance phenomena. Right? Very basic concept. So trying to capacitance technology for the energy storage devices and to fulfill the requirement today's era, like high speed energy storage technology, right? And high power density, energy density. So concept is basically capacitor only. So fundamental is okay. Then how basically other parameters being influenced the device performance, if we will go accordingly, some new methods may require, some chemistry may require, if we are looking for biosensors or biologists, or biotechnology people may require. So if we are connecting them, then yes, this is an endless process, and electronics requirement may never basically isolate. I think that continuously we have to upgrade, and people are upgrading it. This required in need of the nation, need of the world, need of the society as well. Thank you.
So thank you. Very interesting perspective. So now, because this is being organized by II India, and we know that II India is the largest body of engineers, and it started in 1920 under the Royal Charter. So it is the oldest also, and it has a checkered past. What I want to know from all the panelists is that because some members are from the industry and some members are from the academia, industry thinks that academia is not producing the engineers that are capable to, not easily they can be this thing. Last year, I think Wipro chairman Premji had that 50% are not directly employed or something like this. And they say that curriculum is not keeping pace with this thing, with the industrial requirement. And industry people have the complaint with the thing. Academia people have the complaint with the industry that industry is not doing much more for the research and development. Their main focus is that price. Like if it is available cheaply from the China, they would obviously go. That is the major factor. So, and AI is coming, and we cannot stop that. So, what AI will have on this thing, and how AI can be helpful in our curriculum for research, and how that bridge can be, that gap can be bridged with academia and industry. So, anyway.
Actually, the curriculum, which you are saying, this is very important because industry sees the curriculum. It's not the students know. The thing is, they have 4 years. And when we design curriculum, we can say, keep aside the industry. We should not. Focus, as I said, should be on real world problem solving. If AI is there, all models are there, even then this skill is very important for students. Another is critical thinking. The students should have this sequence skill, the critical thinking. Because otherwise, everything can be done by AI models. Okay, so there is no need. So it means you have to identify the problems which, when you are solving, the problems you are solving in a very different manner. Not the concept of, I suggest one thing, all the students should be allowed using these AI models. They can, you can say, use, no problem. But the thing is, first of all, they should solve the problem themselves and then use the AI models and see what solution AI model is giving and what solution you have created. And then compare. That way the different kind of learning is there. Another thing is, I suggest in every, you can say, core courses and elective courses in curriculum, there must be course project. Course project means, suppose, say, take any architecture course or maybe this BLSI design course. Now, in this, they should be given the course project so that they can take it, because this is a course project and then the weightage will be there, then industry problems can be identified. For that, first of all, the faculty has to work closely with the industry, find out what are the problems. I give you another example. You see, we are talking about the big things like the CPU architecture, the GPU architecture, NPU architecture. Don't you can say, have students that, okay, develop this. No. They can identify small, you can say, modules in that architecture and they can have the, you can say, the novel design. Because engineers means they should be a great problem solver, number one requirement. Another is they should be a great designer. And designer should not, that design should not be created by any AI model. I give you the example in NYU, National New York University. The assignment was given in VLSI design course, that is, design this processor. Use ChatGPT. Students, you can say, get the design. But no understanding was there. If suppose they have their, you can say, their own contribution, means they can look at the design given by the ChatGPT, then modify the design. Okay? So that novelty part, they have to focus. And that thing they can learn when they are doing the courses. So they should be open because that kind of thing. Open problems can be given related to that particular subject. Okay? And this is a very, I have tested. Because all the research problems when I formulate the research, it's a big research problem. And then I give a small module for the UG student, undergraduate students. And they, you can say, because it's a very young mind, very fresh mind, different mind, then they give very different kind of, you can say, design of that particular model. And then replace that. So use AI models, and students should not be afraid of using AI models. Because you see, otherwise what companies are doing, they are, you can say, doing layoffs. Based on, oh, this AI model can do, then why should I keep, you can say, person? Right? So that thing they have to learn from the very beginning. In the morning, I interacted one of your students, second year student. I told him that you should, you can say, you must have mastery over that how you can do the different designs, how you can solve the real world problems. I gave the example of the linear algebra course. I asked him that, okay, you have done? He goes, yes, I have done. Then now you attend the video lectures of Gilbert Strong of MIT. It's a very old professor. And then see, linear algebra, he is teaching very differently. And all these things we need in developing AI models or deep learning models, but it's all mathematics. So, two things you have to think, that where the world is going, this is number one, what our, you can say, companies or industries are doing, and those problems the students should do during these 4 years. And final project should be 100% related to the industry. One more thing, if suppose a student has come up with a new novel idea of a different design, new design is there, and he can think of his own or her own startup. Okay, so those things I think you can train the students in such a manner that, because the ultimate goal is to earn dollars. If you focus that, then your life is easy. You can plan your things that, okay, because my aim is to earn dollars. Simple. How can I can, so that sort of learning, I think students should get in these 4 years. It is not only just together this course, that course, grade, all sorts of things. No. They should focus on real world problem solving. That is it.
So real world problem solving, sir.
Let me give my impression. See, we started working on devices, right? Where we control the movement of charge, electron, under electric and magnetic field and electromagnetic radiation. This is in total electrons, where we study the behavior of electron in presence of fields. That's all. Now, we went on making everything small and miniaturization, super miniaturization, ultra miniaturization, whatever you call it, and landed with, it was natural, to single electron. We made single electron device, measured the characteristics and found out everything what it does. With that single electron also, when people started looking at where can it be put to use to. Problems are so gigantic that even that was not sufficient. Single electron device was not sufficient. Then what is next? It was a very serious question. That problems are very big, memory requirements are very large, heat, as Sharmaji has said, is a major problem. So you have reached to the limits. So see, the situation is that we have reached to the wall. What to do? Then people started thinking that can we really do away with this problem in some way? Surprisingly, artificial intelligence, machine learning, and all the related gamut of things working on simulation and computer, running computer and getting the data churned out, churned in, whatever you call it. And I found out very surprisingly that quite a number of problems can be sorted out and their extension can be made to much bigger systems. Well, that's what we are today. Let me think of, forget about electron. Electron has done its job. Data is there, that's okay. Sensor, data is there, after that they forget about it. Now they churn out the data available from there and the data collected so far, not only there, data collected so far. And the gist of all that behavior, whatever they have observed, they try to get something out of it. जैसे नींबू निचोड़ते नहीं है, दो चार ड्रॉप नींबू निचोड़ लिया, and then you go ahead with that. And that is the solution. Now, point is that we have to inculcate that habit. And that habit is very important. Why we have lagged is that we have not created the habit of accepting electronics as the main thing. We have reached, we have measured optomechanical. Everything is fine. They're excellent. Second to none. But in electronics, no. Our boys and girls going there in advanced countries, they are top. Because that mental thinking, mental setup is such that they can assimilate that whole thing. Wherever we do, how many Indian books are there, tell me? People do talk of the law. How many Indian books are there on fundamentals of science, engineering and technology according to Washington et al.? How many? How many colleges are there in this country where they name the college according to Washington et al.? आप तो जानते ही हैं, वॉशिंगटन अकॉर्ड में बी की डिग्री की क्या वैल्यू डिफाइन की गई है और एमटेक की डिग्री किस तरह से डिफाइन की गई है, पॉलिटेक्निक की डिग्री किस तरह से डिफाइन की गई है. आर वी रियली फॉलोइंग दैट? You'll find if you go to Ghaziabad Road, you'll find that so and so Institute of Engineering, Technology and Management, and so Institute of Engineering, Technology and Sciences. My goodness, it's a foolish kind of thing that we have not perceived the basic concept of education, and we are still living in the college age that we are only, trade clerks. I'm sorry. But Macaulay wanted that we should only trade clerks, babus. Now, if we don't change our thinking, if we don't change our doing small bits and pieces here and there and trying to boast that, tomorrow we'll catch up and we'll become a Guru and things like that, that will be only wishful thinking. if you have that kind of fertile knowledge, if you have that kind of experience and expertise, well, put it into this system and do it and show it. Industry will come running after you. In Bay Area, what do? They show the concept, and then industry comes and takes over, and then it starts manufacturing. So, point is that culture has to be developed. I am more worried about culture, I am not worried about minding up with something and then reproducing it in class and things like that. No, that doesn't transfer any knowledge. Because according to the theory of knowledge, only 33% of what you know you can transfer to your students. So if you want to teach a subject which is fully understood by your student, you should be prepared 300%. Put hand on your heart and find out as a teacher how many of us are doing that 300%. So these are the not engineering problems. These are not science problems. No, these are problems with our mind and with our way of thinking. Now, if we don't change that, if we don't come up from different stages of development and try to adjust ourselves, well, the situation is as it is. Nobody has to explain it. We know we are living in that system. So, we have to change our perception, we have to change our thinking. Now, look at the dichotomy. The university says that you complete this course and you take this credit, then only you will get a degree. If a fellow doesn't do that, then he is useless. University has declared that he is useless. It is not clear. On the other hand, industry wants come what may. चलो भाई हमारा काम करो, तुम सबसे अच्छे हो. You will be paid much more than what others are paid. So, point is, where is the harmony? Somewhere we are wrong. Everything cannot be right. And there is no one key by which you can turn and say that oh, everything is right, overnight everything will be right. No. It's a hard work. I was going through the development of nanotechnology as some interesting way. So I looked at the early stage of nanotechnology development. Can you imagine? He's spending billions of dollars in outreach programs to tell people what is nanotechnology, how it is different, how it can be more useful, how it can be. There are a number of things. Now it took decades to make people educated about nanotechnology. Still people are skeptical about it. No, if nothing comes, we'll die. They will take all our, we'll be bankrupt. No, nothing will be left out of it. Now, that kind of thinking, that kind of scientific temperament has to be created among all, so that our students, those who, what we teach, can we teach microprocessor design in a class? No. That's not the job. That's not the objective. Objective is to trigger the fellow that yes, he can take it and do it himself. There's no point. When I was doing MTech, when we went to the laboratory course, then we thought that there will be a list of experiments which you have to do, and there will be instructions and there will be all kinds of things. It is normal in the laboratory. So I remember I went there and I asked the professor that, can I have that list? What list? There are books, there is a library. Go and find out what is your experiment, design it, fabricate it, test it, and give it to others to do experiment. And every year, year after year, This was the practice. Point is that it was not best, but I still value that training that they made us to think that no, nothing is ready-made available. We have to work ourselves and we have to create our own environment and we have to learn those things. Then you can take a big thing, no problem. Now that training, my first experiment was, modulator. The simple diode experiment, modulator. I did it. After that, my teacher, he assigned me that you make a 15 megahertz transmitter for, 3 watts power. Look at that. The level. Now, that FM modulator and transmitter has to be designed by me. I said, I can't do because I have not been taught. He said, no. We will take a book, we will sit and we will work it out and we will do it. And believe it, in 1 year's time, I made transmitter of 50 watts power with linearity, excellent linearity, tube model. No semiconductor was there at that time, it was in 60s. We did it. Now the training that, look, you are not going to be spoon-fed, there are books, there are texts, they are available, and you take that and use it and work out the problem and find out the solution. Now this kind of training, no institution will provide 100% training, nothing. Every institute triggers the mind. Those who are good, they trigger better. Those who are not good, they take the common textbook and just pour it out and think that they have done their job. Now, we have gone through all these stages. We know the problems. This is unavoidable. This is unavoidable. We have been talking of this for decades to improve the syllabus, to improve the courses, to whatever. Still people are going to MIT, still people are going to Harvard, and they are doing a good job. Why? Because they get that facility, they get that thinking, they get that environment. Whereas here, if you ask for a multimeter is not available. He is laughing. Multimeter is not available. Now, these gaps are there, and we are human beings. We cannot be, perfect in everything. The only thing is that we have to try to take best out of whatever we have and utilize it and make something workable. Where you can meet somebody's demand. Maybe it is very small, maybe it is very big. It depends. If you can solve a big problem, then you are brilliant. If you solve a small problem, you are earning millions. Maybe. So the value depends upon what is the problem you solve, and the return is like that. So this is basically investment and return. If you do it properly, well, you are the winner. If you don't do it, nobody is going to scold you also. No. Nobody is going to. It's a great irony. Nobody is going to scold that you suffer. No. हमारी भी जिंदगी गुजर जाएगी भाई. तुम भी खा पी करके अपना तैयार हो जाओगे, अच्छे हो जाओगे, and you will not do it. So in this kind of scenario, in this kind of situation, and in India it is remarkable. Contrast is very, very great. There is nothing like, a small gap. No. It's a huge gap. Now that huge gap is still we have to manage. Whatever we can do, little here and there. But don't hesitate to contribute. Always try to contribute it as much as you. This is what I have learned.
Yeah, very interesting. So, Professor Kulwanji, why don't you take it forward? And also, can you add that you are the newest, oldest rather, skill university? That concept, is that concept working? And what is the role of AI, ML, and all these electronics. We are talking of role of MI in curriculum and all these things, and leadership and all these things. So, what is your experience and how do you see the things moving forward?
Yeah. See, actually, what is the challenge and understanding now in India? In fact, when we started the working on particular problems, so we identify the problem from the literature, and we feel, yeah, this is genuine problem, and we have to work on that. But same time, what we did, we tried to find out the solution, and after 1 year, 2 years, we find out the solution as well. But is really this solution is up to the expectation of the industry or not? So after 2 years, we started to discuss with the industry. So now what the change? What we have already started, in fact, in my university, Wisconsin University. In fact, we are not able to launch any new program without industry collaboration. Curriculum and the scheme being designed and developed in the collaboration of the industry partner only. In fact, we started the PhD program also. So problem cannot be approved without industry partners, without industry persons. What is happening? Now we have the opportunity basically. What problems we are understanding through the literature is really industry also need. So time to time industry also able to understand what is the requirement, how they can commercialize your innovation. Right? So these things university already started, and in fact in India also in different state, I think that the government now planning to establish skill university. So not only skill university, I think that everyone can do. I am already doing these things. I visited in a very strong collaboration from IIT Kanpur. Professor Darpandle last talk I have already discussed. I was surprised to see there approximately 30 companies offices in his lab. National Center of Flexible 30 industry offices. So enter there, what they are doing? They are doing embedded, they are doing IoT. So what embedded, what IoT, they are doing basically what the sensor we develop in the lab, in IITs or CSI laboratories or NITs. So as a professor, sometimes we did the PhD, just supervise the PhD candidate, and good outcomes are there, publications are there. IP are also there, but it cannot commercialize because complete prototype demonstration is not there because of embedded gap is there. So industry people working with the professors. So it is really required, number one. So if suppose that Institute of Engineers, I request to you also, if we may have the members from industry who can work as a bridging between the academia. For example, I am working particular, working on particular topic. For example, in management look at on your last presentation, in fact, that at natural frequency. Now it is patented. Now I am personally looking the industry who can basically go for commercialization, fabrication can be done. Right? So I am talking with one of I am talking with I'm looking some Indians there as well. I am looking Singapore as well. But if industry will involve, so my job is over. My team is completed the innovation, IPR is there. So business to business model. Some companies are working. So business to business means they have taken the technology from us and technology being commercialized by standard industry. So in India, in fact, now 700 automation is being launched. So what is the difference between today's situation or 10 years before? If you see 10 years before also we were doing the fabrication. But today government also supporting. So industry people are looking the basically opportunity for commercialization. And in future, or in fact today's requirement, what is the cyber security? So if we are talking cyber security, if it depends on the chip fabricated by other country, if you want to use here in defense application, if you want to use in any lab, obviously I think that we are not feeling that this is safe and secure in future as well. We depends on drone technology by someone else. We depends on robotics technology by someone else. So this India is looking and we require actually today. So my point is that same time when we are doing innovation, immediately we have to build up the relationship with the industry people. We must be open, we must be talkative, we must be collaborative with them, right? And yes, industry also need to look basically what is the opportunity. Suppose that any innovation being done by MCA. So I'm not sure that we will look more demand for royalty or something. Okay, you feel okay, it may be commercialized, you may give the technology free of cost also. So industry got the place, industry got the manpower, and industry got the opportunity to commercialize this technology to another industry. So this kind of culture needs to be developed. I think that we will develop also. And in the same, Tom actually started already work, right? So this is my thought process. So I believe that institutional engineers in this society may basically look into that, and I'm very much sure in future, like in abroad, people are seriously a lot of innovation being developed in university and commercialized by the industry. So this culture also maybe started in India. Thank you very much.
Thank you. So we come to the last segment, and in this segment, I want to, focus on India has a geography, it has history, it has a democracy, it has a demography, and we cannot bulldoze our policies like China do. So, and we know we are still a developing country, so funds and all these things are still there. So which are the skill sets pertaining to electronics we should focus, government should focus, and what any policy change you want to suggest to the government, considering that everything cannot be addressed. And I would also request you that because we are a old nation of young people, we are the oldest civilization, but demography-wise we are young. So how that it can be inculcated in our policy, how that can be addressed in our policy with regards to future of electronics. So can you tell about this issue?
I can give one domain in electronics and communication engineering. And because I belong to the chip design kind of thing, and it is a very safe kind of field, where there is not much investment is required. Why I am saying, I am not talking about fabrication. And from the very beginning, I don't favor that, okay, we should go for fabrication. It's a very big country. We have huge manpower. We have, suppose in a class of 130 or 240 students, today we see undergraduate ENC program at number of places. Basically, you can produce, suppose, say, not 120 out of 120, 100%. You can say that, okay, if suppose 60 students are, you can say, focusing only on the chip design, and then novel chip design is suppose is developed by say YMC University, I give the example. Then what you can do, you can go for IP, intellectual property, and that you can say you can export. Then you can give it to big houses like NVIDIA, Qualcomm. Intel is nowhere nowadays. AMD you can think of. I give you one very, you can say, why I am saying that you should focus only on future. Don't go for the design kind of problem which does not address the requirement of future. You have to think first of all what is future. In 2014 I visited his forum, the Intel setup, complete setup, and I met one manager there in R&D, you could say, section. And the way he, you can say, was telling, I told very clearly, bluntly, I told him that, okay, the Intel will go down. Mark my words. Intel will go down. And today you see it, Intel, it's nowhere. Because now today, the people are talking about the AI processor. And then pioneers, you can say, look at Qualcomm, AI processor, Snapdragon. So think in terms of where future lies, and then you can give the design problems, because you need to consider computers, right? And then you can divide the problems into sub-problems, and then you see, then you have the network of machines, and okay, you can have, you can say, 60 students working on say 60 machines, so 60 CPUs are there. And the teacher who has given, the faculty who has given the problem, that will work as the server. So it's basically the 60 CPUs working in the server, and then you can think in terms of only one design out of one class. Okay? And that you can work it. If you ask, let's say, government money, means because government is also having their own, you can say, limitations, right? So But the main thing is focus only on industry, because money you can get from industry, but you have to show in the very first, you have to show something that okay, yes, I have the capability, I have done this design, maybe this design is useful to you. So first of all, go for the IT, intellectual property, and then you can market it. Okay, so this is one way where you can think of.
So I'll break from the sequence, and I want Professor Purvat to pitch in here, and then the Professor Samin Ahmed will have the last word for this.
Yeah, I completely agree with sir, because sometimes we should look basically today what kind of resources we have, and as if we are expert in optimizing the structure of any kind of device, right? And that is required for basically for society. Like I mentioned clearly, recently I also developed a MEMS impedance through cytometric device, and that can detect at early stage cancer cells, right? And at the short frequency. And now IPR is granted. So the same things basically we can start from different institutes. Yes, problems, as I earlier mentioned, that it should be genuine. It is basically need for society for future, right? And definitely I think that we can fulfill the basic requirement of the industry as well. Thank you.
I just want to add one very interesting thing. You see, in the first year class, right? Though they have not done any, you can see the design course, this thing, isn't it? In the first year. At Pittsburgh, I think it is in 2011 or 12. One student, you can say, asked me that, okay, can you suggest me one project? In the first year. During summer, because I want to do something. Then I suggested one thing. You know addition and multiplication? Well, yes, I know addition and multiplication. Then I think you can think in terms of, you have done this, you can say the simple logic design kind of things. You know the gates and other things. Well, yes, I know all these things. Then I suggested that why don't you design approximate adder or approximate multiplier? The application, I tell you what is the application. In all DSP application, all you can say image processing application, there is a processor. It does only addition and multiplication. But for, because when you want to recognize an image, there is no need to go for the 100% accurate hardware. You can sacrifice accuracy. And that way what you can do, you can achieve, it will be low power. Your latency, you can get improvement in latency. Then give done the design of an approximate multiplier, and that multiplier design is published next year, in the second year, in VLSI Design Conference. It is a top conference. I think it is in 2012. He published that paper. Another thing I did, go for a very different kind of technology. Technology means reversible logic. That time it was very popular. Reversible logic. Design reversible multiplier. And that also published. It is not that the first year, second year students, when they can do this, if you look at the third year and fourth year, they can do wonders. But you have to identify. And applications are there. Don't, because they give the problem which does not have any application. So that the student will be interested to, you can say, do that thing. Okay?
Yeah, very relevant. Sir, why don't you take up the issue, and because how can we prioritize our policy and what sector should we focus more on?
If you ask my opinion, again, it may be quite different from what others think. Yes, no problem. That's how it progresses. If we want to really progress in electronics, we should synergize our efforts. Means it should be a multidisciplinary approach where different disciplines help each other to find out the solution to find out the ways to do it, to find out new things to be done, and then you can solve a problem in totality. Synergy is a must. I am sorry to tell you, after spending about 50 years in this area of R&D and different disciplines, we completely lack synergy. We completely lack collaboration, intergroup collaboration. We completely lack intra-group collaborations also. If you are a professor, you have 3 students graduating, they will not talk to each other and get help from them to sort out their problem. The point is that we talk big things, we are very fancy, we have a fancy for it, and well, it is our ego, we satisfy that we have talked something very great. But point is that how much I have helped my colleague, by the way of my learning, I have made him learn something new and do something that is own. How much I have. Sincerely ask yourself every day in the evening, you will find that you have done nothing. We talk of interdisciplinary, we talk of, industry, academia, all borrowed words. All borrowed words. Because if somebody says in the States, next day it is the buzzword. I have seen the spurt of solar cell, the spurt of high temperature superconductor. People claim that they have made superconductor, room temperature superconductor are bogus from my institute. And when I told them that, before telling these things, please be careful, they didn't like it. Now, point is that we have seen all these kinds of tides, all these kinds of heights and whatnot. And it will come also, in future also you will see that the situation is safe. More or less say, no, nothing is going to change. Because we are placed in such a way that, it cannot change. Only if we can foresee that whatever we do, we take the advantage of synergy. Today, no subject is pure subject. Like, if you take mathematics, mathematics has got no meaning if it is not applied in it. What is the purpose of mathematics? That will be writing books. Similarly, electronics, you may be having, done a lot, all kinds of things. But if it is not put to use, no point. I tell you, in our scriptures, there is a dua, means supplication to Almighty. Prophet is asking, "Oh God, give me knowledge which is useful." Think about it. If you ask anybody from the religious side, they least understand this dua. They will say, "Oh, you are scientist, useless. You don't believe in God." Whereas, from where everything is started, 1400 years ago, a man asks the Almighty that please give me something which I can put use to. Not simply it should be scripture, no. Knowledge and scripture may be good, but point is that are you going to put it to use? No. So, our aim should be to learn something which is useful to the humankind and take all the resources, not excluding human beings, all the resources We borrow machinery, we don't borrow intellectual property. You know? भाई हमारे हमको कंप्यूटर दे दो, ये नहीं कहेंगे कि हमको ये समझा दो या हमको ये पढ़ा दो, ये नहीं कहेंगे, ये कहेंगे हमको भाई कंप्यूटर दे दो, हम कर लेंगे. Now that attitude we have to break, and that is where these societies, those who are running these organizations, will contribute a lot if we can inculcate these habits that we work together. We don't work in isolation, and it has been proven by semiconductor industry beyond doubt that without collaboration nothing works. So, if positively you can inculcate collaboration and cooperation in your small group, you have done immense service to the community of engineers in a real sense. Start it from today. Do it.
Very good. Yeah. So now we conclude and we open the session for audience. So if audience want to have.
Yes, Dr. Debri, it was a nice and disseminating knowledge and all those things that we have listened very carefully to all the panelists. So I'm sorry to say that your whole panel is from academia. There is none, but no person is from industry. Yeah.
That is the good.
Being from industry, if you permit, I can come and say a few words what industry wants.
Please. Welcome.
Mr. Mandade, National Vice President, our Chairman, Mr. I.S. Subroy, Dr. Dimri, Honorary Secretary, IAI Faridabad Local Center. I am being associated from this. Thank you.
Yes, thank you, sir. Thanks for thought. Industry person comes chair.
Person on the chair.
And by the way, all have worked with the industry.
Because Sir has extensively worked, he has also worked, I have also worked.
It's okay. So let me introduce me first. I am associated with this IAI local center since its inception in 2009. So we have interacted with both industry as well as academicians. I myself has got 50 technical papers published in different languages. But as such suggests, we have compartmentalized the whole system. Academia has got its own ego issue, which I found. I said, told about bridge between academia and the industry. I tried, now I am 60. I started my working life at the age of 25. So, I've tried to bridge between academia and the rest. I've been visiting faculty. I'm a consultant now. So, consultants have taken advantage of this, divide between the industry and academia. I openly say. So, that's one issue which needs to be thought of. Because academia thinks as a revenue generation thing from industry. Any problems they share with
you see academics, they ask for such a huge price which the industry needs a cheaper solutions. That's a very big gap. And secondly, there's another thing is we have capitalization. What we have the panel discussion was on future of electronics and other engineering. You see, if you see the history of engineering, earlier it started from a military engineer. Military needed an engineer. So there was only one branch, military engineering. A military engineer was used his intellect to find the solutions. So with the passage of time, different things came up. And they are also now like ECE corps, civil engineering, military engineering services, now electronics and all those things. A very good thing has come in this panel discussion. As you said, synergy. This what solution I find? Collaboration. So Shunim also. Collaboration is so very now the need of the hour. Electronics cannot be faded away. These are the buzzwords. Earlier, all these things were taught in electrical engineering only. That's the course. Everything was there. This is the institution, the business in the academy has created all these branches. I tell you, I am from architecture. There is only one degree, civil engineering, architecture was part of civil engineering. So what academia has done, there is a business intellect. They, they create the more intake on their institutions, they got architecture aside. Then there are a number of architecture institutions now. What they are doing, they are further subdividing the course. And a very funny thing, one college has advertised, there's a landscape architecture, interior architecture. These are just small chapters. And very funny thing, one ad I saw, architecture college in architecture college bracket mein architecture. So this business attitude should be not with the academy, should be academia. Earlier times, if we learn from our graduate science, Gurukuls and all those things were away. Their job was only to do the research and development and think of what the humanity needs. They need an environment. So we are now, everything is hodgepodge. Business has gone into institutions, and those industry, there, as he said, is a buzzword for them. R&D is nothing. They are doing R&D. They are hiring consultants, getting the problem solved, and that's the thing I think. So the solution is only collaboration. Electronics engineering, no, it will not going to fade away. This is again a buzzword created by this computer science was also part of this only. Now they see, now this computer science is not getting much. Our students are not being placed. So now AI is part of computer science only. So that kind of a thing should not be there. Our system should also try to understand it. If you want to develop, or the simplest way is yes, collaboration. We produce all kinds of engineers to collaborate. And second, another thing which I want to say. ये BTech में सब डिवीजन नहीं होना चाहिए. This specialization should be on MTech level only. You see, all type of smaller solutions, smaller problems can be, even a general patient, MBBS person can, solve all the issues of general. Now, even a small, if you want to get a cut thing, if you have got some vessel or some coming out here, people go to, this MD or MS surgeon for removing that more.
Then what BTech people will do? So,
I think I'm enough to say.
Yeah, thank you.
I have got one recommendation, very strong recommendation.
Yes.
The institution of engineers, the big society that you told, one of the oldest one,
And largest in India.
largest in India. Why don't you take this task of running number of programs to clarify sciences and polytechnic? All the four branches have been very clearly